Okay, so this circuit is controlling a DC motor here, and we need this 9-volt battery for additional power because the Arduino with 5 volts isn't powerful enough to power the DC motor. You have your power and ground coming here to the breadboard, and power on the yellow wire to the push button here, and the push button has ground through the 10 kilo ohm resistor through the red wire. This orange wire here is connected to digital pin 2, which is reading the input of the push button, essentially telling the DC motor to turn on and off. This piece here is the transistor, which is a device that operates as an electronic switch. It controls the high current and high voltage of a component, in this case the DC motor. The bottom, the third pin, connects to ground through this little red wire. That leg is called the source leg. The second or middle leg, which is connected to the component, in this case the DC motor, is connected to this red wire. That's called the drain leg. And the top wire, the top leg is called the gate leg, which is connected to the Arduino digital pin 9 through this red wire, which is connected. That leg's connected to the power. And when you provide voltage across the gate leg, it closes the circuit between the other two pins, the source and the drain. And in doing this, the transistor can turn the high voltage or high current of the motor on and off through the Arduino, when normally it couldn't, but the transistor allows for that. And then this piece here is the DC motor, which essentially converts electrical energy into mechanical energy when electricity is applied to its two leads here, power and ground. It uses a process of induction, which is basically when coils of the wire inside the motor become magnetized inside the copper housing when the current flows through them. These magnetic fields attract and repel magnets, causing the shaft rod here to spin. It spins in the direction that the electricity is given, so it can rotate in either direction. This also poses a potential problem for the circuit. It could potentially damage it through that process of induction, because when you let go of the push button to stop supplying energy to the motor continues to spin because it has inertia. And when it spins, it generates voltage in the opposite direction that you gave it, or the push button gave it. And for this reason, you put a diode here, which only allows for current to be flowed in one direction. So the diode takes that back voltage or reverse voltage, what it's called, which potentially damages the circuit, and flows it into the ground of the DC motor, bypassing the rest of the circuit, essentially protecting it. So that's what the diode is for. And then this orange wire here connects the entire circuit to ground, so Arduino to ground, ground to ground, and then ground to the 9-volt battery. And then when it's all hooked up, when you push the button, it makes this little piece of wood spin. This little piece of wood right here spin. So it's spinning. And then when I let go, it's going to continue to spin for a little bit, and that's the back voltage that can potentially damage your circuit. See how it keeps spinning a little bit? And the diode sends that extra current to ground to protect the circuit.